Welcome to Brain Vision.
So in this question, we have two standing waves, one on each side of a rope, and these two standing waves are given by this y, one with a plus sign and one with a minus sign. And we need to find a couple of things. Let's first look at the first ABC part. Part A, we need to find the frequency. Well, how do we find the frequency? Frequency is omega over 2 pi. And we can read what omega is from this equation because this part should be in the form of kx plus or minus omega t. So what is omega? Omega, it's easy to mistake it as 8 per second, but we need to remember that there is also this coefficient pi over 2 over here. So omega is actually pi over 2 times 8 per second over 2 pi. So frequency is 2 hertz. And then we can look for lambda. Lambda equals 2 pi over k. What is k? Again, we need to consider this pi over 2 over here is pi over 2 times 2 per meter. So it's 2 meter. Part C, the velocity. Velocity is lambda times frequency. Wavelength times frequency. So 2 meter times 2 hertz is 4 meter per hertz. Okay, so now let's look at part D to part I. This question really do have a lot of parts. In part D, we're asked for x larger or equal to 0, what is the bottom of the node? Having the smallest, second smallest, and third smallest value of x. Okay, what is the location of the nodes that have the smallest, second smallest, and third smallest value of x? So if we have the standing wave, it's for x equals 0, it's going to be some form of, I'm guessing, but it's something like this. And we are looking for the nodes with smallest, second smallest, third smallest value of x, and then we are also looking for the antinodes with smallest, second smallest, and third smallest value of x. So it's easy that once we find the first and the second one, it's easy to find the third one because the amount of delta x between each node is actually the same. So we really just need to find the first one or two. Okay, so this is a question in which we might need to think about what y1 plus y2 be like. If we have two equations like cosine kx plus omega t plus cosine kx minus omega t, we can write them as cosine kx cosine omega t. The first equation will be cosine kx cosine omega t minus sine kx sine omega t, and the second one will be cosine kx cosine omega t plus sine kx sine cosine t. So when you add them together, the second term cancels, and you're left with 2 times cosine kx cosine omega t. So if you add y1 and y2 together, y1 plus y2, you will be left with 2 times ym cosine kx cosine omega t, which is, in this case, it's the same except that we know ym equals 6, k equals pi, and then omega equals 4 pi. So let's see D, what is the smallest node? Well, what happens at the node. A node is when cosine kx equals 0. When cosine kx equals 0, cosine kx equals 0, so that means kx must be, let's actually draw a cosine graph. So this is a cosine graph. If it's 0, it must be these points. So it must be n pi plus 1/2 pi. Okay, so, and then x must be equal to n pi plus 1/2 pi over k. What is k? K is pi over 2 times 2 meter inverse, which is n plus 1/2. All right, so with that, we can say for x larger than or equal to 0, doesn't matter because 0 is not a point anyway. X can be, so the unit is meter. For d, the smallest one is 0.5 meter. And then for part E, it's 1.5 meter because n equals 1. And then for part F, it's 2.5 meter because n equals 2. Okay, and then for GHI, we're looking for antinodes. Well, for looking for antinodes, we're looking for when cosine kx equals 1 or negative 1. So kx equals plus or minus, so kx equals, again, plus, it's these values, so kx equals n pi. And again, if we do the same calculation, because k equals pi per meter, x equals n meter. So for part G, what is the smallest antinode for x larger or equal to 0? It is 0 meter. And then for part H, when n equals 1, it's 1 meter. For part I, when n equals 2, is 2 meter. So 0 meter, 1 meter, and 2 meter are the smallest x values for the antinodes.